Hello and welcome to Light Bearers. So today we will determine the collapse load of this frame, given that our plastic moment MP is 28 kilonewton meter. So first of all, let's find the degree of indeterminacy ID. The degree of indeterminacy for a frame is given as 3m plus r minus 3n, where m is the number of members. We have three members here: member AB, member BC, and member CD. And then R is the total number of reactions. We have 6 reactions here: moment at A due to fixity, vertical reaction at A, and horizontal reaction at A. Moment at D due to fixity, vertical reaction at D, and horizontal reaction at D. And then N is the number of joints. We have 4 joints here: joint A, joint B, joint C, and joint D. Now let's substitute into the equation. We have 3 multiplied by 3 plus 6 minus 3 multiplied by 4. So we have 15 minus 12, which gives us 3. Now let's find the number of plastic hinge. Number of plastic hinge equals ID plus 1. So we have 3 plus 1, which gives us 4. Now let's draw the beam mechanism and calculate for the unknown parameters. The angle here is theta, and the angle here is also theta. The linear displacement at load point is given as delta. The angle here is the sum of these thetas, so we have 2 theta. Now let's take this section and calculate for the unknown parameters. Tan theta equals theta. Remember, tan theta is given as opposite all over adjacent. So theta equals opposite all over adjacent, which is delta all over 6. So now delta becomes 6 theta. Now note this: wherever there is a moment, there is a plastic hinge there. And then wherever there is a load, there is also a plastic hinge there. There is a moment at B, and there is a moment at C. So there is also a load at the center of the beam. So we have another plastic hinge here. So the beam has 3 plastic hinge points: 1, 2, 3. Now let's find external work done. External work done equals load multiplied by delta. So for this beam, we have our load to be 12W, And delta from our calculations is 6 theta. So we have 72 W theta. Okay, let's calculate for internal work done. Internal work done equals plastic moment MP multiplied by sum of theta at plastic hinge point. Now, our MP is 28 kilonewton meter. So we have 28 multiplied by, and then we have 3 plastic hinge points here. 1, 2, 3. And then when we sum these thetas, we have 4 thetas. Theta here, plus these 2 thetas. So we have 28 multiplied by 4 theta, which gives us 112 theta. Now let's apply the principle of virtual work, which states that external work done equals internal work done. So we have 72 W theta equals 112 theta. So let's make W the subject formula. So we have 112 theta all over 72 theta. Theta cancels theta. So W becomes 1.56 kilonewton. So let's call this W1. Now let's draw the sway mechanism and calculate for the unknown parameters. From our calculation, the frame has 4 plastic hinge points. Remember, wherever there is a moment or a load, there is a plastic hinge there. There is a moment at A due to fixity. So we have one plastic hinge here. There is a moment at D due to fixity. So we have another plastic hinge here. There is a moment at C and there is a moment at B, which makes it 4 plastic hinge points. Now let's find the external work done. Remember, external work done is given as load multiplied by delta. So our load here is 25 W. So we have 25 W multiplied by delta. Our delta is 6 theta. So we have 6 theta. So external work done equals 150 W theta. Now let's find internal work done. Internal work done equals plastic moment MP multiplied by sum of theta at plastic hinge point. Now, there's a plastic hinge here, there's a plastic hinge here, there's a plastic hinge here, and there's a plastic hinge here. So let's sum up the thetas. We have 1, 2, 3, 4. So MP is 28 kilonewtons. So we have 28 multiplied by 4 theta, which gives us 112 theta. Now let's apply the principle of virtual work by equating external work done to internal work done. We have 150 W theta equals 112 theta. Now let's make W the subject formula. We have W equals 112 theta divided by 150 theta. Which gives us 0.75 kilonewton. So this is W2. Now let's draw the combined mechanism. Okay, from our calculation, the frame has 4 plastic hinge points. So we have a plastic hinge here as a result of fixity, and we have another plastic hinge here as a result of fixity. There is a moment here and there is a moment here. So I prefer here. So we have another plastic hinge here, remaining 1. So there is a load here, so we place the plastic hinge here. Now let's find external work done. Remember, external work done is load multiplied by delta. So our load is 12 plus 25, which is 37 multiplied by delta. Recall, delta is 6 theta. So we have 6 theta, which gives us 222 theta. Now, let's find internal work done. Internal work done equals plastic moment MP multiplied by sum of theta at plastic hinge point. Now, there is a plastic hinge here, there's a plastic hinge here, there's a plastic hinge here, and there's a plastic hinge here, which makes it 4. But then there is no plastic hinge here. So we'll sum up the theta at plastic hinge point alone. There's a theta here, so we have 1. There's no plastic hinge here, so we leave these 2 thetas. There's a plastic hinge here, so we have this other theta, which makes it 2. We have this other theta, which makes it 3. And then we have this theta, which makes it 4. And then there's a plastic hinge here. We have this 2 theta, which makes it 6. So substituting, we have 28 multiplied by 6 theta, which gives us 168 theta. Now let's apply the principle of virtual work by equating external work done to internal work done. So we have 222 W theta equals 168 theta. Now let's make W the subject formula. We have 168 theta all over 222 theta. Theta cancels theta. So we have 0.76 kilonewton. So our W3 equals 0.76 kilonewton. Now, we are asked to find the collapse load of this frame. And the collapse load of this frame is the minimum collapse load. Our W1 is 1.56, our W2 is 0.75, and our W3 is 0.76. So the minimum collapse load is 0.75.